Well, we have a question here. The question says, given h of x equal to 2x minus 3 for -2 less than or equal to x less than or equal to 4, the x-intercept h is q. Now, in the previous videos, we did question 5.1 through 5.3, as you can see there. And now we're going to do question 5.4. Question 5.4 says, for which value or values of x will h of x equal to h minus 1 of x? So now I'm going to move my board over here. Okay, I think I can just do it over here. 5.4. So we want h of x equal to h minus 1 of x. Now, we do know the value of h of x. H of x is given 2x minus 3. Okay, but what we don't know is h minus 1 of x. Now, to find h minus 1 of x, it's when we're going to manipulate the variables of h of x. So we're going to change x by y and y by x, okay, to find h minus 1. So y, we call it x, and then x, we call it y. Now, this makes x is equal to 2y minus 3. And if I need to find y, I move the -3 over, that becomes x plus 3 equal to 2y. So I can divide both sides by 2 to get rid of the coefficient of y, okay, because these two will cancel. And the equation will become x plus 3 over 2 equal to y. This is h minus 1, okay? H minus 1 of x is equal to x plus 3 over 2. Now that I have h of x, I also have h minus 1 of x. I can now find the values of x for which the two functions are equal. So by equating the two functions, okay, I'm going to set 2x minus 3 equal to x plus 3 all over 2. Now we can solve this by cross multiplication, right? Remember, 2x minus 3 is like over 1. The property says this. I'm going to take 2x minus 3 over here. I'll times it with the denominator of the other function, and I'll take the denominator of this function here times it by the numerator of the other function. So that's called cross multiplication. So it's like 2 times it's like 2 times 2x minus 3 equal to 1 times x minus 3. Okay, let me split the board like this. Now move it over. For x minus 6, if I times 2 in the brackets, equal to x minus 3. Now move the x over. That makes 4x, excuse me, 4x plus 3 here. I move the x plus 3 over, that becomes -x minus 3 equal to 0. 4x minus x makes 3x minus 9 equal to 0. Now you move the 9 over, -9 over 9, 3x equal to 9. Now we're going to divide both sides by 3. We divide by 3, we divide by 3 there. And then what you have, x is equal to 3. So now we have the value of x. Now this is the only value of x for which the two functions are equal. So, excuse me, you can solve this in different ways. Okay, another technique is that we do know that for if the inverse functions are both symmetrical on the line y equal x. Okay, so we will say that because initially y was equal to 2x minus 3 for h of x. So we're going to set this equal to x. So this is like equal to x. Okay, so I'm going to say 2x minus 3 equal x. So if I move the x over, I move the -3 over, this will become 2x minus x equal to 3. That means x is equal to 3. So it's the same value we got over here. Okay. So this is a different way to solve the same problem. Thank you. So now let's move on and then look at the following question. Look at question 5.5. Now we're doing question 5.5, and the question says P of X is the point on the graph of H that is closest to the origin. Calculate the distance OP. Okay, so we are looking for now this distance OP. Okay, and then they say that P of X is the closest. Okay, this can be closest if the two lines are perpendicular. Okay, you know, let me give you an idea. Let's say I put two lines over here, and then do a different color. Let's say I have two lines over here. Now we have a point here and another point there. So this distance will be shorter than this distance. Okay. So now why? Because here they're perpendicular. So it's something like we need to have a perpendicular angle over here for us in order to have like the shortest distance. I hope this makes sense. Then let me move over. Let me move my board over here. I'm going to say question 5.6, or I mean 5.5. Okay.